Welcome to Comsworth, everybody. This session is called Demystifying Teams Local Media Optimization by John Stewart Murray, an AudioCodes Senior Pre-Sales Consultant. Over to you, John.
Okay, thanks a lot, Lee, and good morning, everyone. It's a bit early in the morning for this kind of thing, but I hope your brains are fresh. So what I wanted to do today was talk about a new feature in Teams called Local Media Optimization. You may well have heard of it, and it's a kind of supplement to an existing feature in Teams called Media Bypass or Direct Media that's been around for some time. So I'm going to go through that in a bit of detail and just try and outline the kind of features and benefits and use cases of when you would use Media Bypass and an LMO. We'll have a Q&A session at the end, by the way, and then there's also a breakout session after that. So I'll kind of go through these now fairly quickly, and if you can hold any questions, I'll type any questions into the Q&A panel, and we'll take those at the end. Just a very quick overview on AudioCodes then. So we've been around for 25, 26 years, quite a large company in this space. We're about 700 to 800, I think, almost employees worldwide now. A really strong focus on Microsoft solutions. So I think about 50% of our revenue goes through Microsoft in some way or the other. Market through systems integrators and service providers. So we're always working through our systems integrator channel, essentially. So kind of value-added partners that we work with and train up. And we see our role really as a kind of trusted advisor for telecommunication solutions. You know, we're scattered throughout the world. We see all the things that the customers are doing and our partners are doing. And I think it helps us kind of have good insights into what the world's doing. So just a very quick look at our product portfolio. If you haven't heard of AudioCodes before, we've got a lot of products. Let me just bring up a little pointer. Okay, we have a lot of products in AudioCodes, and they kind of go from the got a pen. They go from the kind of the SBCs and stuff down here that people are probably familiar with, and the small ATAs for connecting analog devices to Teams. And if I've got a presentation on that, I think tomorrow sometime, about connecting analog devices to Teams. So do join that. Yes, up through SBCs, from little to large, and a strong focus on software SBCs. I think probably about 70 to 80% of our SBCs now are software based, so in Azure, AWS, or VMware, that sort of thing. We also do a lot of phones, Skype phones, Teams phones, SIP phones, and meeting room solutions as well. So we do now collab bars are coming out quite soon, and we do very small conferencing solutions. And then right at the top, we've got loads of software of different things. So management software for users, management software for applications, management software for devices, and also call recording we do. So we've just announced our Teams compliant call recording solution. And again, I've got a presentation on that in the next couple of days. Anyway, that's enough about AudioCodes. Yes, so let's have a look first of all at Media Bypass in Teams. So I'm kind of assuming that everyone on the call is familiar with Teams direct routing. So we'll kind of rattle on a little bit. So if we look at how Teams works at a kind of a call flow level, when Teams client is calling a Teams client, so over here we've got a Teams client, and over here we have another Teams client. When they want to talk to each other, they use a REST protocol to transfer the signaling. So if I want to call my colleague Ewan, then I click on Ewan's name, and then Teams sends a message down to Ewan saying John is calling you. So that's the signaling part taken care of. It used to be SIP in the old days, but now it's this REST-based protocol that Teams uses. So once the signaling is set up, we now need to set up the media between the two parties, so myself and Ewan, essentially. We're both for firewall, and ICE's job is to get the media in the best way possible between myself and Ewan. It may use functions within the Office 365 network, like the media processors or the transport relays. And again, we haven't got time to talk about that today, but we can discuss it at other times if need be. But essentially, ICE's job is to get the media from one client to the other as quickly as possible. Sometimes the media can't flow directly, so it goes to Teams media relays. And the same situation may happen when you have an SBC involved in Teams direct routing. So what we have now is we have the client down over here, and over here we've got the SBC used in direct routing, and the same process happens. When a call is set up, essentially the REST call goes up. When I want to call this telephone number 01252759150, a message goes to Teams, and then Teams converts that to SIP and sends it down to the SBC, because the SBCs talk SIP, they don't talk this REST protocol. So that's the signaling kind of setup, and now we need to connect the media between the client and the SBC. So typically the media goes through Teams, and it has until about a year ago always gone through Teams, but that's not always the optimal path, of course, because sometimes it's quicker to go directly from the client to the SBC, or send the media directly from the client to the SBC. So in this case, what we can do is enable something called media bypass. Now, when media bypass came out about a year ago, it was just basically a tick box in the configuration of the SBC. You just said turn on media bypass, and then Teams would try and set up the call so the media would go directly from the client straight across to the SBC. Of course, ICE was used in this as well, and the transport relays and the media processors were used to try and get the call or the media from one place to the other as quickly as possible. So you'll notice once we've got the media going, of course, we can choose which codec we're going to use, and we'll look at that in a bit more detail later on to see the different advantages of which codec to use. But these are the codecs up here, Silk or Opus, which is actually being deprecated now in Teams. So typically we try and get the media going from the client directly to the SBC using media bypass. So if we look about what that looks like in kind of the real world, basically, and take a step back. So in this situation, you've got an SBC situated here. So this could be this could be a hosted SBC in the cloud if you're having a Teams hosted service, or this could be your enterprise, your corporate, and you're kind of wandering around working from home, perhaps. So if you want to make a call via this SBC without media bypass turned on, then the media goes up into Teams, and then down to the SBC, and then down to the outside world, down here basically. So the media call flows across with the signaling to the SBC, and then out to the PSTN, and out to make a phone call. So it follows the same path with media bypass turned off. But if you turn on media bypass, you then get the ability to be able to send the media directly from the client to the SBC. So you can go straight from here to here without having to do that double hop through the Office 365 Teams network. So that allows you to optimize the media path. So you might have some kind of MPLS connection, for example, between your client and your SBC. So you can use that to have QoE on the link or QoS on the link. So you can optimize the call quality potentially. So it gives you more ability to make sure the call is over high quality. If you're local to the SBC, so if we then change the scenario slightly, so now we have an SBC sitting in a kind of a local office, and the client is now sitting down in the office down here, so it's no longer external, then media bypass can be used in this environment as well. Okay, so when you make the call, the signaling and the media normally go to Teams, and then the signaling and media come down from Teams and then go out to the SBC. So this is without media bypass. Yeah, signaling and media flow up here, and then flow back down again, and then out through the SBC and out to the outside world, which is the normal flow. And again, that can work fine, but obviously what you're getting is quite a lot of traffic going out through the corporate firewall, and then back in through the corporate firewall and across over here. And this guy is actually could easily be about 5 feet away from this SBC on the local LAN. So it makes sense to be able to use that connection essentially. And the way we can use that connection is by turning on media bypass. So we turn on media bypass, and what we hope is that the media can then go directly from here to here. But what actually happened in the older version of media bypass is not quite that. Essentially, what happens is, sorry, let me get this build going. What actually happens is that because the Teams and the SBCs use something called ICE Lite, in the old media bypass days, the SBCs could only present one external IP address, and the only address they could present to the outside world is this address here. So if the client wanted to send media to the SBC, it had to use that address, which meant the traffic, or the media traffic, used to go out of the kind of corporate firewall, back in through the firewall, and then zoom into the SBC, and then go off to the outside world down there, which is obviously very suboptimal. because you're kind of trashing the corporate firewall by sending these thousands of packets a second in and out. I mean, sometimes you can do a hairpin on the firewall and just flip it back again, but it still uses a lot of processing power on the firewall to handle these kind of things. So it's not always an ideal scenario. So media bypass was introduced about a year ago, as I said, and it worked quite well in some scenarios, but this specific scenario here didn't work very well, when the client was connected or on the same LAN as the SBC. So Microsoft were working for some time on this thing called local media optimization, and this was released about 2 months ago. And it's supported by most of the kind of major SBC vendors, but there are different implementations. And you can look at LMO or local media optimization as kind of media bypass on steroids, I guess. It's a sort of enhanced media bypass, but it has lots of extra roles. And what it does is it uses the location information services and the location-based routing data that's in Teams to enable the SBCs and Teams to have location information. So you're probably familiar with LIS and LBR, that when you set up Teams, you can kind of create sites and locations within the kind of corporate network. And this is then used in these new SIP headers. So now when Teams sends calls to the SBCs, it sends down these SIP headers with the extra information in them. So they now have a flag which says internal or external, which basically tells the SBC that the client is internal to the corporate network or external to the corporate network. And it also has the site location in there. So you might have, John is based in site London, and then the SBC knows where it is as well. So it helps to understand where the SBC is in relation to the client. And it also have things like trusted IP addresses are also in there. So this means that Teams and the SBC can now work together, which gives you kind of what we call smart call handling. So we can have, it's a couple of extra options basically. So we can now have new topologies in Teams and also many more media path options. So let's look at those in a bit more detail. So the key benefits really with local media optimization is that it fixes the problem with the local clients that we've just seen, where the media goes kind of out of the corporate firewall and back in the corporate firewall again. But it also allows us to start creating more distributed topologies of SBCs. So if you've got a large corporate wide area network, for example, you can use that to transport the media more easily than you could before. So you can use your corporate network because it has high quality and it's secure to move the media around to the right place. And I'll show you some scenarios of that in a minute. It also allows more flexible topologies. So there might be scenarios where you've got remote branch sites that don't have an external IP address, for example, don't have a public IP address. And that means they can't usually use the Teams SBC because that needs a public IP address. So there's this concept of proxy and downstream SBCs that we'll look at in a second as well. But one key point to note is that the original media bypass is still supported. So LMO is a kind of an enhancement to media bypass, but you can still quite happily use media bypass. And it's often recommended to use media bypass because, as we'll see in a minute, LMO is quite complicated to set up and it's easy to get it wrong, essentially. So as a prerequisite for LMO, what you need to do is go into Teams and then set up your sites and networks and trusted IP addresses in Teams. So if you've got 4 or 5 sites, you need to define your sites and then use these kind of PowerShell commands like this. Then use CS Tenant Network Subnet to define an IP address and tell it which network site it's associated with. So then the whole world knows that that's the internal address which is associated with the site London. So there's quite a lot of prereq work to do to get LMO up and running. But once it's running, it gives you some significant advantages. So if we go back to the scenario we had a few minutes ago, where this user, this client here, is sitting on the same LAN as the SBC. So when he makes his call, you actually get a SIP header coming down saying John is internal and his address is 192.168.1.0, because John has sent this message up to Teams and then Teams then sends it down to the SBC. So the SBC's got 3 bits of information: John's internal, this is his address, and also which site he's in at the moment. So now the media can use the internal interface of the SBC. So we're not constrained anymore via ICE Lite to be able to use this address. We can actually use an address over here, another address on the SBC, and we can now send the media directly into the SBC and then out to the outside world. So as you can see, that gives you a much more optimal path. Essentially, we're no longer having to, either go out through the firewall and back in again and then out over here. We can now go directly up into here and then out to the outside world. So that's a really key advantage for LMO. It allows you to use that internal interface. So it gives you the chance to maximize call quality. Now, if the client is external to the site, essentially, so he's not on the corporate LAN, it looks quite like it looked in the old days with media bypass. So the client's sitting here, you turn on LMO, and the media goes to the SBC and then out to the outside world. So it looks like nothing really has changed. But let's talk about transcoding, because it's an important part of Teams direct routing. So we talked about this before, that when you're negotiating the call setup, then Teams will negotiate a codec, and a codec is used to change the voice stream into IP packets, essentially. So when you're talking as I am now, a codec takes my voice and then just chops it into little IP packets and sends it out. There's different kinds of codecs, and they basically have different call quality and different bandwidth requirements. So Silk supports these codecs. Sorry, Teams supports these codecs: Silk, G722, G711, and G729. And these are basically ordered in quality order. So Silk is the best quality, and then the quality kind of goes downhill from here to there, basically. And really, you should never use G729 if you can get away with it, because it's a pretty poor codec. Silk, on the other hand, is a fantastic codec. It's really good at poor quality lines, and it's also a wideband codec as well, so you get great voice quality. So we're using Silk probably at the moment to talk, and it's very good call quality across any kind of network, essentially. So Silk is great to use if you can. If you're on a poor quality connection, if you're on a Wi-Fi connection, it's an internet cafe, for example, then it's great to have Silk to sort of send the traffic from the client to the SBC. However, if you think about the total call from end to end, obviously the SBC is connected to the PSTN, and the PSTN pretty much always uses G711. So if we're going to use Silk from the client to the SBC, but we're going to use G711 from the SBC to the PSTN, that means the SBC's got to transcode. Yep, it's got to change Silk into G711, which many SBCs can do, but it is heavy lifting. So these are kind of typical figures, but if you've got a hardware SBC, then you can typically see a reduction in capacity of about 25%. So if you had an SBC that could handle 400 calls, if you turn on transcoding, then it may well go down to 100 calls, for example. So you get a quarter of the capacity. Or if you're using a software SBC in Azure, you might need to go up 3 or 4 virtual machine sizes to keep the same kind of capacity you had before. So transcoding is useful, but it's very heavy on resources. And this is where LMO is very useful, because it lets you use transcoding wisely. So what you can do, for example, you can define clients to be in different groups, because now the SBC knows where the client is. It can then turn on the transcoding for the client if it thinks it needs it. So if it sees an external client coming in, so when this call comes in, Teams says, oh, this client is external, his IP address is 212.17 so-and-so. The SBC knows he's external, so not on the corporate LAN, so it may be useful to have Silk turned on for this call. So this guy uses Silk here and G711 down here, so the SBC is then transcoding. But if you're an internal user, then the SBC knows this user's internal, so it then puts him into the G711 pot. So now we don't do transcoding for these calls, and we just send the traffic here and here, but with running G711 in and G711 out. So that lets you use, for example, say if 90% of your calls are internal, you could have G711 for those calls, and if only 10% are external, you could turn on Silk for those calls. So it lets you kind of right size the resources on the SBC. So you don't have to have full fat, kind of Silk to G711 on every call. You can kind of put the right calls to the right people, and that's really valuable because it means that people that are having poor connections get the best codec, and the people that don't need it get G711. But it also lets you do things like have different qualities of service. So if you're a hosted provider, you might be able to kind of sell Silk connections slightly more expensively than the G711 connections. So G711 tends to work okay most of the time, but you can give kind of guaranteed SLAs where you say that we're using Silk on this connection, so it's going to cost you an extra £1 a month per person, but you get great call quality at all times. So LMO enables that quite easily because it lets you have the user location and therefore the appropriate codec. So that's a key advantage of LMO. So another advantage of LMO is that we can then set up different networks and different topologies of SBCs. So if you think about a large enterprise, they typically have a corporate wide area network of some kind. So you might have a central office, in London, for example, with a large central SBC up here, and when you can have users. Lost my mouse completely. You can have users there we are. You can have users, local to the London site, and you can have users kind of floating around, in internet cafes and working from home and stuff, all making calls down through this SBC and out to the outside world. If you've also got offices in, for example, sort of Berlin and in Paris, you can set up the network to use the wide area network for the media, essentially. So we've got LMO turned on with media bypass enabled, and we set up our network sites correctly. And then we can make sure that the corporate network is used to transfer the media from one place to the other. And the signaling always goes up to Teams up here, but the media can follow this path here. So again, if you've got a good corporate wide area network with MPLS links between the two, you don't need to bounce your media off into the internet and back down again. You can utilize the local, your local wide area network or your global wide area network to send calls across, and that gives you the ability to have great call quality and SLAs, obviously, to your end users. There's another way that we can use these topologies as well, and we can then have what we call distributed SBCs. So in this case, you'll see that the remote offices are now more widely dispersed. So we've got an office in New York, an office in Singapore, and then you've got a central site in London. Now, when you've got these kind of scenarios, you really don't want to be sending media all the way from Singapore to London and then go out onto the PSTN. Within Europe, for example, media usually has very low delay. The network has very low delays, so it might be like 10 millisecond delay from sort of Paris to London. But once you're in Singapore, you're starting to get in the kind of 100 millisecond plus delays, and then you can start getting call quality problems. So echo starts to creep in when you get to over about 200 milliseconds. And echo is so destructive for phone calls. You probably know when you've been on phone calls with echo, it just makes it almost impossible to talk. So what you need to do in those environments is to use the distributed SBC topology that you can have with local media optimization. So you can set up these SBCs in the New York office and an SBC in the Singapore office, and then you can make sure that the media goes in the right place. This also has an effect, of course, if you've got local regulations where you need to use local PSTN. So, for example, in some parts of India, some parts of the Middle East, you can't make international phone calls using voice over IP. If you want to make an international phone call, it's got to hit the PSTN in that country and then go across the PSTN interconnects, so that the local countries can sort of monetize those phone calls. So LMO allows you to do that, basically. So it lets you quite easily kind of sort out the routing required, so that if a user is in the Singapore office, for example, then his media can go to the Singapore SBC and then out onto the PSTN. And similarly, if you're on the New York office, your media can go to the New York SBC and then out onto the PSTN. But it also lets you overlay many more complex scenarios that we haven't really got time to kind of go into in great detail. But you can have different scenarios. For example, you can have a setup where you don't have kind of corporate, you don't have external IP addresses for these SBCs here. So in the previous picture, this SBC would have had a connection back up to Teams, using the internet, because that's the way a Teams SBC needs to work, essentially. Let me just go back to that picture. But that may not be the case. So, for example, if this location here doesn't have a public IP address, I mean, this could be, for example, a financial institution, and it doesn't want to put its SBC out onto a public IP address and exposing it to the outside world. If you don't want to do that, you can configure what we call the proxy SBC and downstream SBCs. So this SBC up here then becomes the proxy SBC, and this becomes a downstream SBC, and they're configured differently in Teams. So this SBC is configured differently in Teams than this one is, and then what happens is the media and signaling, media call flows can go, from Teams to this SBC, down the wide area network, and then out of this SBC out to the outside world. So it means this site is kind of protected from attack because it's just on the corporate network. It's not on the internet. So it makes it easy to roll out these more complicated and diverse scenarios. As I said, these can get quite complicated, so they're not always advised to be used unless you know exactly what you're doing, essentially. But it does give you the ability to do lots of different call flow scenarios. Okay, so I've missed a summary there somewhere. Sorry. Yeah, so if I just want to find a summary, 2 seconds. All right, I do have a summary slide, but it seems to have disappeared. There we go. Yeah, so I'll read the summary slide out now, essentially. So media bypass, as I mentioned, is still supported. It's recommended for less complex scenarios, recommended for hosted SBCs. So if you're a small hosted service provider, then using media bypass, a standard media bypass is recommended because it's quite easy to implement and deploy, and you can make sure the media goes to the right place. But LMO definitely has a place, as we've seen. One of the key advantages is you can use that internal interface for local users. So if you're sitting on the same site as your SBC, you can send the media directly into the local SBC's interface. But it also lets you use the more complex scenarios where you can use Silk for external users and G711 for local users. So you can kind of right size the transcoding resources on your SBC appropriately, which is a really key advantage with Teams. And as we touched on kind of briefly, it lets you set up these distributed SBC topologies, with proxy central SBCs, downstream SBCs, and so you can use sites that don't have wide area network access, don't have internet access, to be able to still have a kind of full Teams deployment. But LMO is complicated to set up, as I've said. You need to configure all the LBR and list stuff, trusted IP addresses, sites, etc. The SBC configuration can get quite complex, so it's worth kind of factoring the fact that you may need professional services for successful deployments, or you need to spend a lot of time understanding how it works and testing and improving it. Okay, so that's on the half an hour. That's pretty much all I wanted to talk about. We're going to jump into the Q&A session now, and then we'll have a breakout session after that if we need any more conversations. But don't hesitate to contact us if you need to at any time. You can get hold of us at uksales@audiocodes.com. We're always there to kind of help you, essentially. Okay, Lee, can you open up the Q&A if there's any questions?
Yes, thank you. Good session, John. So we have a few questions. I'll go through them. So this one is, does media bypass have to be enabled for the SBC and Teams for LMO to work? Is it a prerequisite?
It is, yeah. So as part of LMO, you have to turn on media bypass. So even if you're not using kind of the old media bypass, you still need it enabled. Yep. Okay. That's a good question. That's sorry, I should have mentioned that. So yeah.
Next question is the LIS, so location information services, and LBR, location-based routing, data also required if I have only a central SBC with LMO, e.g. for Europe, and no downstream SBC?
It depends if you want to use the internal external attributes, because if you do, the only way of turning those on is by using essentially the LBR list stuff. So yes, if you think you might need to use that bit where we have the G711 for local users and Silk for external users, then you still need to define your kind of sites and trusted IP addresses to enable that functionality. So yeah, but it is more simplified. That it's not that complex, that scenario.
Okay, next one is morning, John. Great presentation. Thank you. Question for you: when configuring LMO, is it a case that a public certificate is assigned to the external SBC interface and an internal certificate for the internal interface?
No, you can just do a well, actually it depends. It's a good question, actually. You may need to have the actually, sorry, it's a big question. There's different scenarios. So sometimes you might need to use a certificate with 2 SANs, for example. That's one way of doing it, because you can set up the 2 different topologies like that. With LMO and the proxy, you just have one certificate, and you don't necessarily need certificates for the downstream SBCs. It depends on the scenarios. It's quite complicated, but so it's sort of yes, and yes, I'm afraid. So sometimes you need two certificates, sometimes you need a wildcard certificate, and sometimes you will only need one certificate, and it does vary quite a lot. So it's probably best to ping me directly if you want, and we can discuss it in more detail.
Okay, great, thanks for that. So the next question is, does China Firewall make any difference in terms of deployment and design of proxy SBC for APAC sites with Teams direct routing?
That's a good question, actually. To be fair, I don't really know, because I don't deal with. I mostly deal in the UK, basically. My colleagues look after other sites, but yeah, China is like India and some parts of the Middle East, that they effectively have they need location-based routing essentially. The media has to hit the PSTN; it can't go through VoIP. So effectively, yes, it does, because you can't pass it through the firewall. It's got to hit the PSTN. What you do with things like users outside China that might want to use the services of an SBC inside China, I don't really know how that works. I would imagine, yes, I don't know how that works, I'm afraid. So yes, in many scenarios, the China Firewall, as it's called, will stop media flowing. So you have to use LBR and LMO kind of functionality. Yeah.
Okay, great, thank you. Someone just comments, AudioCodes rocks.
I'm sure it's my marketing director who's probably did that. So.
Yeah. Next one is, generally SBCs are hosted in data centers and internal clients are on a different network locations. Can LMO be implemented in this scenario?
It can do, yes. You just need to be careful how you manage your networks, essentially. As long as there's a path between the client and the interface, then you can use it. We didn't really talk about the transport relays and media processors in Teams, which do play a part in this. So they tend not to be used with LMO. They tend to be used more with media bypass, but they can still be used with LMO. So you just need to understand how the Office 365 network works, because Microsoft's got a fantastic global network, and they've got these transport relays scattered everywhere, and their job is basically to get the media from the client to the SBC as efficiently as possible. So they can help you, but yeah, if you do have the kind of fairly typical scenario of a SBC in a DC and users on within the corporate network with a separate LAN, it still works fine. It's just typical IP routing. That's all you need to do. Just make sure they can see that path to the internal subnet. Great.
Okay. And the last question is, do you plan to support SATIN codec?
We don't currently know. It's currently just used for peer-to-peer calls, so that there's no real advantage at the moment in SBC use. And we have Silk basically, which works superbly. So most of the kind of chipsets and DSPs we use don't actually support SATIN, so it's a significant change. So and I don't expect to see it in SBCs anytime soon, and maybe never at all, in fact, because I think Silk does the job. We used to have Opus as well. In fact, we still have Opus in the SBCs, but Microsoft's pretty much deprecated Opus now. It's just focused on Silk. So yeah, I don't think it'll be used as far as I can tell.
Okay, great, thank you. With that, I think that's all the questions. Let me just double check. Yeah, that's all the questions. So I think that's everything really. As John mentioned, we're going to have a breakout session now, so I'm just going to quickly post a link into the announcement area with a link to the breakout session, and if you'd like to join us there in a couple of minutes, that would be brilliant. Thank you.
Are we going straight into that, Lee? Are we going to go in at 2:15, or what's the?
I think let's go in now. Yeah, at the end of the session. Yeah.
Fine. Okay, I'm going to find my link, but I'll be there in a couple of minutes.
I've just posted it in the chat. There you go.
Oh,
John.
brilliant. Okay, fantastic.
Yeah.
Okay, thanks a lot. Well, hopefully see some of you there.
Yeah.
Cheers then. Bye.
Thanks, everyone.